Hello, I'm live and let's begin. For today, we were on chapter number 2 in our C journey. Journey. Where were we? So, um, yep, we were at arithmetics, declarations, arithmetic operators. Now we will continue and not hopefully, but we are the only deciding factors. Complete this chapter. How long is this? It is about relational and logical operators. Then we have type conversion. Then we have increment and decrement operators. Okay, and then bitwise operators, and assignment operators, and expressions and conditional expressions. And this is the last topic, precedence and order of evaluation. And then there are somehow no exercises. So let's complete this whole chapter today. That is the goal. But if at some point I feel like we are losing quality, then we will stop there or we will go very slowly, even if we are unable to complete the target. Because quality is the main thing here. And is the stream not? Yep, stream is not stuck. That is good. Let's begin. The relational operators are this greater than, equal to, less than, equal to. They all have the same precedence. Just below them in precedence are the equality operators. Well, I think we did this yesterday, but okay. They all have the same precedence. Just below them are in precedence are the equality operators. So first these are evaluated and after that these are evaluated. Relational operators have lower precedence than arithmetic operators. So an expression like I less than lim I minus 1 is taken as I less than in bracket limit minus 1, as would be expected. More interesting are the logical operators and or. Expressions connected by and or are evaluated left to right, and evaluation stops as soon as the truth or falsehood of the result is known. Most C programs rely on these properties. For example, here is a loop from the input function getLine that we wrote in chapter 1. Input function getLine. Yep, I equals 0, I less than limit minus 1, and so this is evaluated first and this and then this. C is not equal to end of file and C is not equal to new line. Increase I and put Si equals C. Before reading a new character, it is necessary to check that there is room to store it in the array S so that I is less than limit minus 1 must be made first. Okay, moreover, if this test fails, we must not go on and read another character. Similarly, it would be unfortunate if C were tested against end of file before getchar. Therefore, the call and assignment must occur before the character in C is tested. Yep, the precedence of and is higher than that of or, and both. Okay, so and is evaluated before or is higher than that of or, and both are lower than the relational and equality operators. Expressions like this, okay, and both are lower than relational and equality operators. So expressions like this is evaluated, and this is evaluated, and this. No need no extra parentheses, but since the precedence of not equal to is higher than assignment, parentheses are needed. Okay, here parentheses are needed. This to achieve the desired result of assignment to C, then comparison. with the new line. By definition, the numeric value of a relational or logical expression is 1 if the relation is true. By definition, in the numeric value of a relational or logical expression is 1 if the relation is true, yep, and 0 if the relation is false. The unary negation not converts a non-zero operand into 0 and a 0 operand into 1. A common use of not is in constructions like if not valid rather than if valid equals 0. Okay, it's hard to generalize about which form is better. Constructions like not valid read nicely if not valid, but more complicated ones can be hard to understand. Write a loop to evaluate to equivalent a loop equivalent to for loop above and or without using and or. Hmm. I can write e- multiple loops, right? The thing is that I will have to check these conditions, this condition, this condition, and then this condition, and only move on if all of these are true. So for that, I can make a separate for uh, I can make a while true loop, and inside that I will see. Wait, I have to write a for loop. So I will do a for loop where I will be less than equal to this, and then inside the for loop I will get if get char is not equal to new line, and then inside that if condition I will say for if c is not equal to end of line. Yep, and then I will write what I have to write. Yeah, that makes sense. Type conversions. When an operator has operands of different types, they are converted to a common type according to a small number of rules. In general, the only automatic conversions are those that convert a narrower operand into a wider one without losing information, such as converting an into integer to a float point in an expression like f plus I. Here, the integer will be converted to a float type. Expressions that don't make sense, float as using float as a subscript are disallowed. Okay, expressions that might lose information, like assigning a longer integer to a shorter type or a float point type to an integer, may draw a warning, but they are not illegal. A character is just a small integer, so chars may be freely used in arithmetic expressions. This permits considerable flexibility in certain kinds of character transformations. One is exemplified by this naive implementation of the function atoi, a that is ASCII to integer, which converts a string of digits into its numeric equivalent. A string of digits, a string a to a convert string to integer, takes in a string and initializes I and n equals 0 for I equals 0, si greater than 0 and less than equal to 9, I plus plus, n equals 10 into, oh, 10 into n, I increase n by 10, so I get a new digit, and there I will add that minus 0. Okay, that makes sense. As we discussed in chapter 1, the expression this gives the numeric value of the character stored in AI because the values of 0, 1, etc. form a continuous increasing sequence. Yep. Another example of char to int conversion is the function lower, which maps a single character to a lowercase for the ASCII character set. The character is not If the character is not in uppercase letter, lower returns it unchanged. Lower takes in a character, and if it is greater than or equal to capital A and less than in equal to Z, returns C, the character, minus capital A, that is the offset, and plus A. Uh, Now, this would be, yeah, character minus capital A will give me the offset from the starting character, and then to that I add the base, which is A. And then if it is not, then I return C, the character itself. This works for ASCII because corresponding uppercase and lowercase characters are fixed distance apart and as numeric values, and each alphabet is contiguous. There is nothing but different letters between A and Z. This later observation is not true of E, B, C, D, I character set, however. So this code would convert more than just letters in E, B, C, D, I. Okay, the standard header ctype.h described in Appendix B defines a family of functions that provide tests and conversions that are independent of character set. Conversions that are independent of character set. For example, the function toLower is portable replacement for the function lower shown above. Similarly, the test is digit is can be replaced by is digit. Okay, we will use the C-type functions from now on. Okay, C-type is a library standard header which contains the header files for functions, defines a family of functions that provide tests and conversions that are independent of character set. Okay, so it doesn't matter if we are using ASCII or whatever, they would help us. Okay, we use these from now on. There is one subtle point about the conversion of characters to integer. The language does not specify whether variables of type char are signed or unsigned quantities. Yep. When a char is converted to an integer, can it ever produce a negative integer? That is a good question. The answer varies from machine to machine, reflecting differences in architecture. On some machines, a character whose leftmost bit is 1 will be converted to a negative integer sign extension. On others, a character is promoted to an integer by adding zeros to the left and thus is always positive. I think always positive part is more seems more natural, and yeah, seems more natural. The definition of C guarantees that any character in this machine's standard printing character set will never be negative. So these characters will always be positive quantities in expressions, but arbitrary bit patterns stored in character variables may appear to be negative on some machines, yet positive on others. For portability, specify signed or unsigned if not character data is to be stored. Right. So these characters will always be positive quantities in expression, but arbitrary bit patterns stored in character variables may appear to be negative on some machines, yet positive in others. Okay. For portability, specify signed or unsigned if the non-character data is to be stored in a character variable. Okay, I will keep that in mind. Relational expressions like I greater than j and logical expressions connected by and or are defined to have value 1 if true and 0 if false. This argument, this d equals c greater than equal to 0 and c less than equal to 9. I will get the digit in d. Sets d to 1, right? Because assignment has a higher precedence. Okay. Set d to 1 if c is a digit and 0 if not. However, functions like is digit may return any non-zero value for true. The test part of if, while, for, etc. to true just means non-zero. So this makes no difference. Okay. Implicit arithmetic conversions work much as expected in general. If an operator plus or multiply that takes two operands. A binary operator has operands of different types. The lower type is promoted to the higher type before the operation proceeds. The result is of the integers type. Okay, lower data types are converted to higher because when you convert a lower data type to a higher data type, then no information is lost, first of all, and that is I think the main point. And if you were to convert higher data type to lower data type, then information could be lost. That is a bad sign or omen. Shit. The result is of the integer type. Section 6 of Appendix A states the conversion rules precisely if there are no unsigned operands. However, the following informal set of rules will suffice. If there are no unsigned operands, however, the following rules will suffice. If either operand is long double converted to other long double. Okay. Otherwise, if either operand is double, converted convert the other to double. Okay. If either operand is float, convert the other to float. Otherwise, convert character to short or to int. If either operand is long, convert the other to long. Yep, okay, makes sense. Convert from the smaller data type to the lower, higher data type. Notice that floats in an expression are not automatically converted to double. This is a change from the original definition. In general, mathematical functions like those in math.h will use double precision. The main reason for using float is to save storage in large arrays or less often to save time on machines where double precision arithmetic is particularly expensive. Conversion rules are more complicated when unsigned operands are involved. Why are they more complicated when unsigned numbers are involved? You can just add zeros in the start. The problem is that comparisons between signed and unsigned values are machine dependent because they depend on the size of the various integer types. For example, suppose that int is 16-bit and long is 32-bit. If int is 16-bit and long is 32-bit, if then -1 long less than one unsigned bit, one unsigned integer, because one u, which is an unsigned integer, is promoted to a signed long, but this unsigned long but this because -1l is promoted to unsigned long and this appears to be a large positive number. Because it has one at the start and this because this -1l is promoted to unsigned long and this appears to be large positive number. Conversions take place across assignments. The values of the right side is converted to the type of the left, which is the type of the result. Conversions take place across assignments. Conversions take place across assignments. The value of the okay when I am assigning, and if the data types do not match, then the value on the right is converted to the data type on the left. That is to the type that I am trying to give the value to. Of the right side is converted to the type of the left, which is the type of the result. A character is converted to an integer either by sign extension or not, as described above. Long integers are converted to short ones or to charts by dropping the excessive high order bits. Thus, int I and char c and I equals c, and the value of c is unchanged. The value of c is unchanged because its original value was extended and that extended value got truncated, like the higher bits of that extended value which were added and which are possibly only zero were dropped and given back to C. This is true whether or not sign extension is involved. Here is reversing the order of assignment might lose information. However, when I am, yeah, yeah, that would lose information. If x is float and I is int, then float equals int. That is good. And int equals float. Both cause conversions. Float to int. I is int, and I am assigning integer to float. But float is a bigger data type, so that is good. Float, x is float, and into a float to int causes truncation of any fractional part. Yep. When a double is converted to float, whether the value is rounded or truncated is implementation dependent. Okay. Since an argument of a function call is an expression, yes, type conversion can also place when arguments are passed to functions. Can also take place when arguments are passed to a function in the absence of a function prototype. Char in short become int and float becomes double. This is why we have declared functions argument to be int and double, even when the function is called with char or float, because they will not lose data at least. Finally, explicit type conversions can be forced, coerced in any expression with a unary operator called a cast, like this brackets, and inside those brackets type name, and after that put expression. The expression is converted to the name type by the conversion rules above. The precise meaning of a cast is as if the expression were assigned to a variable of the specified type. The meaning of a cast is the meaning of a cast is as if the expression were assigned to a variable of the specified type. Expression were assigned to a variable of the specified type, which is then used in place of the whole construction. For example, the library routine square root expects a double argument and will produce nonsense if inadvertently handled something else. Square root is declared in math.main, so if n is integer, we can use convert n into double and then pass it to square root to convert the value of n to double before passing it to square root. Note that cast produces the value of n in the proper type. N itself is not altered. The cast operation has the same high precedence as the other unary operations as summarized in the table at the end of this chapter. Okay, so this does not change the value of n itself, it just provides a new value to the square root function, which is a converted type of the value of n into double. If arguments are declared by a function prototype, if arguments are declared if arguments are declared by a function prototype as the they normally should be, the declaration causes automatic coercion of any arguments when the function is called. Thus, given a function prototype for squirt returns a double and takes in a double. The call square root equals 2 is automatically converted from integer to double. Coerces the integer 2 into the double value 2.0 without any need for a cast. The standard library includes a portable implementation of a pseudo-random number. The standard library includes a portable implementation of a pseudo-random number generator and a function for initializing the seed. The former illustrates a class. Includes the implementation of a pseudo-random number generator and a function for initializing the seed. The former illustrates a cast. Hmm. Let's see what this number is. Random. Rn means random and D means digit. return pseudo random integer on this number. Okay, int rand does not take anything. It just, what does it do? Takes next is something, does next, and next to multiply by a big number, and then return unsigned integer. This divided by this. Okay, is rand, set seed for rand, return pseudo. Okay, and next is here. What is strand unsigned int seed? Next equals seed. It takes in a seed. Exercise, write a function HTOI which converts a string of hexadecimal digits, including an optional 0x or x, into its equivalent integer value. The allowable digits are 0 through 9, A through F, and A through F. HTOI. Okay. Chapter 2. In chapter 2, I will make an HTOI function. This function will take in a hexadecimal value with an optional 0x at the beginning. This value hexadecimal string, and then return digits, a string of hexadecimal into its equivalent integer value, and then it will return an integer value. Include stdio.h and then int main. Here it will, okay, this main will call the function. The function will return an integer and the name is HTOI, and this will take a char pointer which will be called hex, and then it will do its magic here. What will be the magic? The question is. First of all, I will check if it starts with 0x or not. If hex 0 equals 0, wait, starting can be 0 small x or big X. I should convert it to small. String.h, right? To lower, yeah, to lower is a function. Shit, what does it expect? To lower from C type. What does this function do? Shit, my no information available. How to, there was a function which can convert string to lower in C, and by lowercase a string in C. Ah shit. Oh, it can only lower a character at a time. That will work. That will work. If the first is 0 and the hex second, pass it on to lower. If second equals x, then make hex pointer hex equal hex the address at hex 012 non-void function. Yep, it will return an integer. Wait, Now integer result starts with 0. In the end it will return result, but before that it will go through the array for int I equals 0 and I less than result dot length. Nope, cannot do that. What will be the condition? The condition is this: x I is not equal to null and I plus plus. Okay, thus I will get access to every character in that string. Now I want to convert enums. God damn it, yes, enums. I can use enum here, right? Enum. How do I define enum? Enum. What? Hexadecimal. Is that the correct way? Uh, Here 0 is 0, then 1 expected identifier. This is my identifier. Okay, 0 1. I guess that shit. A equals 10, and then B C D E F. Yep, that is good. Okay, and now I think I can print them. Yep, enum member. What do I want? A switch statement now. What do I want now? Yep, two conditions. If hex I is greater than equal to the character 0 and hex I less than equal to 9, the character value of 9, then I do this. I do result equals result into 10 plus hex I minus 0. Yep. Else I know that it is one of A, B, C, D, E, F. What do I do then? When it is one of them, then I will have to multiply the result by 10. So it should be, if I were to write it in one line, no, multiply the result by 100 because the value can be 10. Shit, god damn it. No, I first have to change it into decimal. Shit, yes, I will have to change it into decimal. That is crazy. Going from the end, I will have to go from the end and keep adding the value. Yep, that makes sense. So instead of doing, I don't have to do this because I will be starting from the end. I need the end for that. Shit. I need to have the end. For let I equal 0, I less than, wait, hex I not equal to null and I plus plus. At the end, I would like to have I, let I And then what do I do? Oh, let is nothing. My bad. Int. Okay, now at the end I will have I. The last element in the string. Uh, the second la last index. So before that, yes, I can do I minus minus so that hex I gives me the last element, the last character in the string, and now I can start a loop for nothing. And while hex I, how do I find? While I greater than equal to 0 and hex I is not equal to x and lower of xi is not equal to x to lower, and then here I will do I minus 1 minus minus. Yep, that is correct. Now result, I have result here. What would I like to do? I would also like to store let place value equals 0. Yeah, place value will not let, this is not JavaScript. Int place value is 0, and then the result at any point would become, well, let me check if the current character xi is integer like this and xi less than equal to 9. Okay, if it is a number, then what do? I make the result equal result plus xi minus 0, so that this gives me the integer value. What do I do with that integer value? Multiply it by place value, and then at the end, no matter what, I will do place value plus plus. Is that correct? Multiply by place value? Nah, multiply by place 10 to the power of place value. So multiply by power, yep, power 10 to the power of place value. What does it take? Parameters overload. That above part should work when the current character from the array is a digit. But now if it is not, if it is A, B, C, D, E, F, something of that, then shit, how do I do it? Switch. Now, do I have to individually do? No, I know it is either A, B, C, D, E, or F, and they appear in sequence. So, yep. I can do, yep, I don't need these, I think. And what I can actually do is this character value for this is xi to get the current character, convert it into lower. First of all, convert it into lower and subtract from it a, so that I will get 0 for a and the increasing values for other, and then plus to it 10, 10, so that I will get 10 if hex1 is a and 11 if it is b, and subsequent values correctly. Yes, then I can just apply this same thing here. Instead of doing this, I can put value here. And then at the end I will return the result. Will this work? This should work. Let me do it. Char pointer x equals 10af ed e of this, and then int h int number equal htoi. It takes in x call. Okay, I have to declare the function before using it. Here the function prototype, and then here I can do printf the integer is %d new line and number. Clang htoi and dot out. The integer is this, and okay, cat htoi. What was the hexadecimal value that I provided? This. Let's see, x to decimal converter. 1749 something something, and the answer is wrong. 10af eft. Okay, let's do htoi instead of this. Let me do a. This should return 10. Not slash out. It does return 10. And what if I do 10? 10 should give me 16. It's 2. Yep, I am so stupid. It should return me 16. So instead of 10, I have to write 16 here. Yep, 16. So now if I go with the original value, which was this, and do nhtoi and go with this here and do clang dot slash out, I get this number, which is 1749 and 1749 7853 7853. Cool. Now this increment and decrement operators, and I think it has been about 40 minutes, 44 minutes, pretty close to the time. Increment and decrement operators. C provides two unusual operators for increment and decrementing variables. The increment operator plus plus adds 1 to its operand, while decrement operator minus minus subtracts 1. We have frequently used plus plus to increment variables, as in this new line plus plus new line. The unusual aspect is that plus plus and minus minus may be used either as prefix operators before the variable, as in plus plus n, or postfix after the variable, as in n plus plus. In both cases, the effect is to increment n, but the expression plus plus n increments n before its value is used, while plus plus n increments n after its value has been used. This means that in a context where the value is being used, not just the effect plus plus and this are different. If n is 5, then x equals n plus plus x equals 5, but x equals plus plus n is first incremented to 6 and then assigned to x. Okay, x sets x to 6. In both cases, n becomes 6. The increment and decrement operators can only be applied to variables. An expression like this is illegal. Okay, these can only be applied to variables. Something like this is illegal. Illegal, like police. In an extent where no value, in a context where no value is wanted, just the incrementing effect, as in this, then we can do anything, whatever we like. Prefix or postfix are the same. But there are situations where one is or the other is specifically called. For instance, consider the function squeeze sc, which removes all occurrences of character c from the string s. This function would be fun to write. We can write it. Squeeze delete all c from s. Void squeeze character s int c. And here we have I and till I and j both are equal to 0. One will contain the index for the original string and one will contain the index for the string that we are going to return, the new string. No, not the new string. We do not have to use a new string. We can make changes to the current one. I is not equal to end. I will supposedly contain the index for the original string I plus plus. If si is not equal to character, then j equals 1. Okay, sj equals 1 and j will be incremented afterwards. Okay, and s equals si, and at the end do sj equals, nope, end of the line. That makes sense actually. Each time a non-c occurs, it is copied into the current j position and only then is j incremented to be ready for the next character. This is exactly equivalent to this. If si is not equal to character, then sj equals si and then j increment. Another example of a similar construction comes from the getAlign function that we wrote in chapter 1, where we can replace this by more compact. This here we have c is not equal to new line si equals c, and then increment I, we can do I increment. As a third example, consider the standard function stircat concatenate string, which concatenates the string t to the end of string s. Stircat assumes that there is enough space in s to hold the combination as we have written it. Stircat returns no value. The standard library version returns a pointer to the returning string. Okay, stircat concatenate t to the end of s. Yep, s must be big enough. Okay, and does not return anything. It takes in two pointers, two characters, integer r and j. I j both are equal to 0, and while si is not equal to, like, find the end of s. Okay, and while si equal to, okay, I started adding the characters of the string t to the end of s. That makes sense. Each member is copied from t to s. The postfix plus plus is applied to both I and J. Yep, to make sure that they are in position for the next pass through the loop. Exercise 2.4. Write an alternative version of squeeze S1 and S2 that deletes each character in S1 that matches any character in the string S2. Hmm. We can do that. And there was also a function which tells me if a certain character is in a string or not. What was that function? They used that function in the first chapter to find out if a character is a punctuation or not. Where is it? That function that they used. It was something like clean line or something. Let me see. What was it? Um, it must be somewhere around here. Hmm, 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 hmm. Hmm. Line countings. I think I lost it. Nope, nope. Before this, it was only the Fahrenheit function. Up, up. They wrote a function to remove all the characters. Shit. Character counting, line counting, word counting. Am I actually hallucinating? Where is it? Was it Stircom? Okay, let me ask Google for that. Increment and decrement operators. Yep. Okay. Function in C to find if a character is in a string or not. Stir char. Stir char. Okay, that is the function. Stir is in a string. Okay. If C is in a string, is in a string, that I will not get null. If it is not, then I will get null. Okay. Stir char. SQU squeeze and squeeze.c. Include stdio.h and then int main and inside, nope, nothing inside, and here return void and squeeze char pointer s1 and char pointer s2, which does something here. What does it do? It will go through for let I equal 0. Yep, I s1 I is not equal to null and I plus plus. Oh, not let. Goddamn. Int. Now, if stir. What was it? Char. Stir char. First of all, it takes in a character array. The character array is S2. Is it if it is equal to S1 I, uh, not equal to, but what does this mean? If this thing is true, no wait, if this thing is not equal to null. If this is not equal to null, then I will do S1 I. No, yes, one for the current index and one for the index that goes forward. And I comma j, and here I will do I equals j. No, not here, but here j equals I equals that. And expected this. Where did you expected that? After the end. Oh, here. Okay. J equals this. Okay. Now, if I know that the current character is not in the list, then I can do S1 J increment equals S1 I. Okay, that I guess makes sense. And let me declare I have two strings. S1 equals this is my original string, and let's see what remains at the end. Now the second string S2 is this is the second string. Let's see now after I have to declare a squeeze over here. Here then I can just do printf s1 no percent s to say that this is a string, and then new line, and the string is s1. Let's see, not this but squeeze, and send the output to the output, and this is my original string. Let's see what remains at the end. Everything remains. Okay, there were some problems. At the end, I have to do not this end, but here at the end, I have to do S1J equals null. I think that should work. Did not. Squeeze dot C. Okay, I did not call the function. That is very stupid. And wait a minute. Just a second. My bad. Okay, yes, let's continue back where we were. It has been 1 hour. Okay, we got this. And yes, I did not all the function that was pretty stupid here. I can call S1 and with S2 and this should work. Dot slash out and bus error. That is pretty unique. Bus error in C. How did I manage to do that? How did I do that? Bus error. Bus error is being caused by this part somewhere in the code. Hmm. What is causing? Yeah, it is not this line. One of these lines is causing the bus error. Here I am accessing this and checking if it is not equal to backslash 0 is no, and then I am passing in these to stir char and checking if the output is not equal to null, and then after that I am doing this s1j equals s1I, and I is incrementing every time and j is not. Why is this causing a bus error? I cannot see any reason why this would cause a bus error. Is this line causing a bus error? How did they do it? Things they are doing things just fine, like with this syntax. Hmm. Should I think you guys can hear my bones cracking. Shit. Um. Why is this causing a bus error? Let me ask ChatGPT. This function is causing a bus error. Why is that? Why is this causing a bus error? It should not. If it's char is not equal, seems good to me. Mistaken writing back to S1. Yeah, why is this condition is incorrect because you are keeping the characters found in S2 instead of removing them. However, that alone would not cause a bus error. It would just lead to incorrect output here. Possible causes of bus error. The main issue is when modifying. Okay, these are pointers to characters. That is also not a problem. Is modifying S1 if S1 points to a read-only string. Example, a string literal. Attempting to modify. This is stored in read-only memory. String literal. So this modifies. Okay, since hello is a string literal, modifying S1 in squeezing leads to crash. So I can make it. Okay. Shit. Yes, that. Makes sense. This is a string literal that is causing the problem. Okay. Out. Wait, why did I do that? Chapter 5. Nope. Squeeze. Yep. What is stopping me from printing? If this is not equal to null, only then do this. This is, and let's see that. Okay. I should not see this is my original string. Okay. What if I make this exactly equal to this? Dot slash out, and this is my original string, and let's see what happens at the end. I get the exact original value. I think this is happening because if it is not equal to null, that is I got it. So I should check for equal to null. Yep, I didn't get anything. This is my second string, and why? LLW are the only characters that appeared in the first string and not in the second string. Okay, now this question. Write function any which takes in s1 and s2, two strings, which returns the first location in a string s1 where any character from the string x s2 occurs if -1 or -1 if s1 contains no characters from s2. The standard library function strbreak does the same job but returns a pointer to the location. It returns the first location, not the pointer but location. Okay. And any find same char dot c and include stdio dot h and then int main, and in there I will write a function that won't return anything. Nope, that will return an integer. That will be the index. Any s1, a character pointer s1 and a character pointer s2, and for int I equals 0, I s1 I is not equal to null character, till then go through it I++, and if in s2 comma s1 I, yep, is not equal to null, then return I, and at the end return -1. Oh sorry, I have to do this str c hr, this, right? Yep, this is seems correct, and now I can declare character pointer s1 equals string, and this is my first main string, and let's see what happens. And char pointer s2 equals z and xxxx, and let's do g g and printf index %d new line, and index is any s1 comma s2, and it returns an integer. Yes. Oh, and is not declared. Clang any, the output should go to dot out. Answer is 27, and let's see if it is actually 27. Um, what do I do? Yes, 27k. Yes, answer is correct. Now, bitwise operators, and not long when this is completed. And how many questions are remaining? Question number 10 here, and then question 9 here, 2 questions, and 3 questions here, 5 questions. Okay, we got this. Bitwise operators. C provides 6 operators for bit manipulations. These may only be applied to integral operands. That is char, short, int, long, and yeah, and these cannot be cannot take place for pointers and for other things like double or float, and bitwise and this bitwise or inclusive. Okay, and this is exclusive or left shift, right shift, one's complement, unary. The bitwise AND operator, this is often used to mask off some set of bits. For example, this and 0, 177. This is uh, okay, sets all zeros, but the lower order 7 bits of n sets all to 0, but the low 7 order bits of n. 7 bits. How does 7? What is 2 power 7? 2 power 7 is if how many, yeah, 2 power 7, how many combinations can there be for 7 bits? Not just combinations, what is the greatest value that can be seen by us while using 7 bits? That would be 127, but this is 177. The bitwise OR is used to turn bytes on, set on, where set on is generally 1, set to 1, and X the bits that are set to 1 in set on. Okay, the bitwise exclusive OR, this sets a 1 in each bit position. This is just exclusive normal OR. It returns 1 if the bits are opposite. Sets 1 in each bit position where its operands have different bits, and 0 where they are the same. One must distinguish the bitwise operators and from the logical operators and or, which imply left to right evaluation of a truth value. For example, if x is 1 and y is 2, then x and y is 0. Yes, while x and y is 1. The shift operators left and right perform left and right shifts of their left operand by the number of bit positions given by the right operand, which must be non-negative. Thus, this shifts the bits of x left by 2, shifts the value of x by 2 positions left, that is multiplying it by 4, filling vacants with 0. This is equivalent to multiplication by 4. Right shift an unsigned quantity always fits the vacant bits with 0. Right shift a signed quantity will fit with bit sign. Arithmetic shift on some machines and 0 bits logical shift on others. Yes, arithmetic shift right or arithmetic logical shift right or logic or arithmetic shift right. Two right shifts are there available to us. The unary operator not not yields one's complement of an integer, that is, it converts each one bit into a zero and vice versa. For example, this and not 77. 77, this is octal. This is a octal number. Yep, this is an octal number, and therefore this 1 represents 1, and this 7 represents 3 ones, and this 7 also represents 3 ones. So there is a logic. This represents 6 ones, sets the last 6 bits of x to 0. Note that this is independent of word length and is thus preferable to, for example, this which assumes that x is 16-bit. X is a 16-bit quantity. The portable form involves no extra cost since this is a constant expression that can be evaluated at compile time. Okay, that makes sense, which assumes that X is a 16-bit quantity. The portable form involves no extra cost because since this is a constant and can be evaluated at compile time, this sets the last 6 bits. Okay, note that X and not 77 is independent of word length and is thus preferable to, for example, this X and this. Okay, okay, this is translated to 1 to the 6 LSB as 0 and the 1, 2, 3, 3, 3, 9, 10. 10 most significant bits to be 1 and the least 6 significant bits to be 0, and this it assumes 6 to be a 16-bit quantity. So that makes more sense. As an illustration of some of the bit operations, consider the function getBits xpn that returns the right adjusted n-bit fit field of x that begins at position p. We assume that that bit position 0 is at the right end and that n and p are sensible positive values. For example, getBits x4 3 returns the 3 bits in position that returns the right adjusted n number of bits field of x that right adjusted begin at position 0. Okay, we assume that bit position 0 is at the right end and that n and p are sensible positive values. For example, get n bits. This gives 3 bits the last starting from the right. Fourth bit returns the 3 bits in position 4, 3, 0, 4, 3, and 2, right adjusted. Okay, it will from the index it will go to the right. Okay, get bits and this unsigned get bits. get n bits from position P. Unsigned get bits. It will return an number, unsigned number, unsigned number. Okay, unsigned integer. It takes in an unsigned x and an integer p and an integer n, and then returns right shifted value of x. Right shifted value of x. Okay, that makes sense. Starting from p, that is p minus 1 minus n, p minus p plus 1. If I right shift x p plus 1 times, that will go there, and minus n. Yep, that makes sense. It's and bitwise and with, if I get 1 and get 1 and left shift it by n, I will get 1 at the positions that I want to make 0 in x, and if I take there not, then I will get 1 in the positions that I want to get the value of from x, and 0 at the position that I want to discard, and then I return that. That makes sense. The expression this moves the desired field to the right end of the word, and not 0 is all 1 bits, shifting it left n positions. With this places zeros in the rightmost n bits, complementing that with not makes a mask which with the ones in the rightmost n bits. Yep. Write a function set bits which takes in this that returns x. Okay, what is this? This takes in 4 numbers and that returns x with the n bits that begin at position P. Okay, to set the rightmost n bits of y that begin at position P, set to the rightmost n bits of y, returns x, leaving the other bits unchanged. X returns x with the n bits that begin at this, set to the rightmost n bits of y. Okay, so I have to get the rightmost n bits of y and replace them with the n bits of x that begin at position P. Okay, that is doable. Of course, that is doable. Set bits dot c include stdio dot h and main, and then set it returns an integer x. Set bits takes in x, p, n, and y, which are all like integers, integers, and integers. And here, first, I would like to have the rightmost n bits of y, and for that, what can I do to get that? Mm, yes, for that, um, let's do int right n of y equals the thing that we did, that we just now we were doing with n, right? I will take not it not of 0, and that would give me 1, and left shift that by n times. This is the symbol for left shift, right? And after left shifting it by n times, I would like to flip its bits like so. And the thing that I get now, I would like to take its OR with y. Y OR. Yep. Now right y contains the rightmost n bits of y. Now I would like to put them all into x. How do I do that? Okay, Hmm, I can surgically do that, right? Something like this. I have the rightmost n bits of y, right? And then let me get make another integer. Let's say integer with y bits, that is x with y bits equals, how do I superpose, how do I overwrite the contents of x with what? Can I do that? Okay, for that, yes. Let me get do x right shifted by p times, because beginning right shifted by p plus 1 times. Okay, and right shift this by p plus 1 times, and then okay, and then the result that I get, I would like to left shift it, left shift it by p plus 1 times, and then take its OR with right and y. Yes, that makes sense. Take its OR with right and y. Now I have the values, and left shift it again by p plus 1 times, and to that I can add no, I made a mistake. Where is the mistake? Yep, the mistake is here when I'm left shifting it for the second time. I want to do this for n times, and yes, left shift it by n times, n times. Yes, by n times. Yeah, then add to it practically the right n bits, and then I have already left shifted it n times, so now I want to left shift it only p plus 1 minus n times. Okay, and now to that I want to take, with that I want to take the or, with that I would like to take the or of, shit, x is least significant, the sum of x's least significant bits, or with, that is just, this is just crazy maths. How many lesbies? P plus 1 minus n. P plus 1, P plus 1, 1 P plus 1 minus n. That is that number. I left shift this by that and then take its not and get that and get that. Okay, yes. Then x with y bits. Answer. That is the answer. Let's see what happens. Printf digit. Printf x equals some number and int p equals, I can tell it in binary like that, right? Let p I can tell in something like this, and int n equals, n is always less than p, so and then int y is x binary print x in binary, then print p in decimal, and then print n in decimal, and then print y in binary, and in here I give p comma n and y, and before that yes, and the answer, print the answer also in binary. Set bits x comma p comma n comma y, and here let me define the function. Set bits x is b. Okay, how to print and assign binary in C. printf n, like okay, let me assign binary using hexadecimal. But how do I print binary? Ah, print print binary is this function. God damn it, I have to print one by one. I can print in hex, that would work. 0x 1f, I don't know, 0x, let's see, right? That should do it. And here, and L long Alex, long, and also this one Alex long, and here also long. Let's see. The answer is well, the answer has changed, but is it equal to y? Make this also long, and let me do starting from the 8th, replace the 4 bytes, that, and nope, and set bits. Question number 17, where am I printing? New line, and output. Okay, the answer is way off the mark. Pretty messed up. Not even close. All that for nothing. Is anyone even watching the stream? Guess, and I hope not. It is just me. Okay, that is cool. It's been 1 hour 40 minutes. That is crazy. Seems like we won't be able to complete this chapter today. That is fine. And like I said, quality. We have to keep in mind the quality of the stream. Well, like I'm not explaining anything, so. But the thing is, these streams are for me, not for the watcher. If anyone can benefit, then that is good. But these streams are for me to get better at coding. This, I know, gets me the last bits, last n bits of y, but let's see it. Does it actually do that? Nope. Nope. It is giving me something else totally. Not totally something else. I'm getting 1BD, 1BD, E and F. Last bit is changing to 1 somehow. Set bits. Yep. So what the heck is this thing doing? Not 0 is 1. And if I'm shifting it, this does shift it to the left, right? This operation is for left shift. Yep, this is for left shift. This is for right shift. So this shifts 1 0 to the left and n times. And then I do its not. And then I take, no, instead of or, I should take and. That makes more sense. Take and. Okay. 1FA2. 1FAB. X is 1 letter smaller. And this is much better than what was happening before. I think I am not shifting properly. And this is giving me the least n bits for X. And then I'm taking its OR. And the least n bits, but the least non-n bits, the bits which should not be changed, and then I am taking there or with this behemoth, whatever this is. Okay, I shift n right by p plus 1 times p plus 1. Okay, here my x, and here is the LSB for x, and this is p. I shift it by p plus 1 times p plus 1. Should I do it p plus 1? Nope. I have to do it p times, and then at the end p minus n times. Let's see. And that is totally messed up. That is not the correct approach at all. So what was the problem there? This 1F2AB, 2A, 1FA2, 1FB, what the heck? It is not even as right as it used to be. Why? This is correct. This is giving me the least n bytes of y. Let's see. Is it? Yep, it is indeed doing that. And let's see then this part. What does this represent? And ABCD equals this all this, and answer is or oh, this is BCD, and put this here. Let me given CD here. Okay, what is ABCD? ABCD gives me 1BFA 2. I also need 2 here, and I want it to be left shifted one more time. Here. When I do this, I make the least P LSB is 0. and then I left shift it by n times, and then I left shift it again by p plus 1 minus n times. This is not making sense. I right shift and then I left shift. The right shift should cancel the left shift. Right shift is for p plus 1 times, and the total left shift is also p plus 1 times. The total right shift is p plus n times, and the total left shift is also p plus n times. Should it be 7? Because the first one I am considering it to be 0. I think the answer is correct, but just the way that I am representing it in binary, I am unable to see the answer, unable to judge if it is right or wrong. See, 1FA, 1FA, 2B, and this is D. 1FA, D. Let me do this with a smaller number. Let's say 3 here and 2 here, and make this F, and I'll make this 0, 0. And let's see how that works out. So Y is 0, and I want to replace FF. FF means 8 1 bytes, and I want to replace 2 bytes of n starting from the third to 0. That would give me 4 ones, that is F, and then 3. Would it give me 3? 3. It would if I consider 3 to be started at 4. Yes. Yes. This is correct. This is correct. This is working perfectly good. And how long has this been? 15 minutes. Let's do one more question, at least one more question now. Write a function invert p x p n that returns x with the n bits that we can add p inverted. That is, 1 changes to 0 and 0 changes to 1, leaving the others unchanged. That is simple. And invert n bits dot c include st, not is, what the heck is stab, std io dot h, and main I have return int, and any word will be the name of the function that will take integer x and integer p and integer n, and then I want to invert int. Okay, let me do this in one single equation. Okay, return, what do I want? I want x to be right shifted by p plus 1 times right, and then left shift that value by n times right, 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 right. And then, okay, but this time I want some other juice. Shit. I want those n values. Shit, 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 shit. Okay, I got this. Now what do I want? I want inversion of 0, that is 1. Right shift that by p plus 1 minus n times. Yes, yes, yes. And then whatever I get. What is the wrong? Oh, okay, okay, okay. Let's put this here for the time being. Yes. Now I have something. Okay, and now I would like to left shift this, the value that I just got. Left shift this by how many times? First of all, p plus 1 minus m to get back, and to get back to the original value. And then I only want those p plus n times. Is that correct? Nope. I want everything else to be 0. Wait, I can make them 1. Can I make them 1? I have everything as 1. The whole thing depends on how I am slicing x. Right shift x by p plus 1 times, and then left shift it by n times. Okay, I have it empty. Now what do I want? I want the inverted values for those n bits. How do I get the inverted values for those n bits? For that, I first of all want those n bits. How do I similarly get those n bits? To get those n bits, yeah, I do not know the number yet. I do not know n and p, so shifting is the only way. Yep, shifting. Yeah, got it. I got it. I got it. I guess I got it. Now in this bracket, I want to have the inverted value of those n bits. and to get the inverted value for those n bits, and do this. Take x, oh shit, take x, right shift that by p plus 1 minus n times. Yes. Now I have those n bits that I required as the LSB. Now I can take its and the value that I just got. I can take its and with take its and with take its and with the number that has ones for its n LSB and zeros for everything else. So not zero will give me one. Right shift that by n times. Yep. And take the and of that, the invertedness of that. This expression will give me the ls, those bits that I want from x. Yep. That makes sense. What the heck? Yep. Now, yes. Now, what do I want? Yep. Now I want to left shift. This is becoming really complicated, but I think this will work. Left shift by this much. I think this will work. And then left shift it, and I would like to take it and with x and with not zero, not zeros, right shift by p plus 1 minus n times. And I hope that this actually works. This behemoth works. I hope. In n wait, index equals 0x and the value is a b c d. Nope. Wait, let's make it whole f, and here int p equals 3 and int n equals 4. Oh no, that is wrong. Make this 7 and this 4, and then printf. First of all, I will make this long and define this above there, and do this x equals %lu and p is %d and n equals %d and answer equals %lu, and then new line, and then provide x p comma n comma invert x p n, and change the output for return index, return type for this too long. And this should work. I don't know, this should work. And does it? Ah, it does not. It does not. Why the heck do I have? Oh, okay. That was the wrong program. Clang invert and make the output out. Not LU, but make it LX. Fucking hell. Yes. Okay, this works. That was good. And what time is it? 2 hours on the mark. Let's see if we can do this. Write a function. Write rot. Shit. This is going to ask me to rotate. That returns the value of integer x rotated to the right by n positions. This should not be that much of a big deal. Uh, rotate right, include stdio.h and int main, and let me define. This will return a long rotate right. It will take in a long or integer, doesn't matter, int x and int n, and inside, okay, in a single statement we are going to do this in a single statement. Return, fuck, first of all let me get the LSB, n LSB for x. For that I have to take n and its and with not 0 right shifted by n times. Yes, that seems good. And take its OR with nah, nope. I I need to know the length of x. I do not know the length of x. X's length. I need to know x, length of x. How can I know x? X's length. Well, I am saying that it is an integer. So would that mm, 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 mm. rotate right by n bits? I need to know the length of x, and since I'm saying that x is integer, so it is 32 bits in my system, but that is not a general solution. But do I want to get a general solution? Rotate right. I want to rotate it right by n bits. The first part gets me the least significant n bits, which will go to the start of n. Well, yes, of course, I can do x right shifted by n, and with this left shift this, left shift this, how many times? The size of x minus n. Supposing the size of x is 32 minus n. Now, if the size of x is 32, then I will get a good answer. But if it is not, then I am messed up. long x. Well, I'm saying that x is long, so that is going to give me a problem. Let me do a, b, c, d, e, f, and int n is 4, the least significant 4 bytes. And here, copy this, go to the top, paste it there, and here let me do printf, and x is percent lx, no, lx, and n is per, wait, I don't have to make this long. I can do this int only and replace even this by int, and make this int, and we have this, and yes, treat everything like int, make this a digit, and answer is also going to print d but x, and this also can become, and here I will give x n and rotate x n. Now, nope, not inward bits. Clang rotate, make the output file dot out, and yeah, I have to change it to um, I have to change it to long. Replace to long, and go back, make this long, go back, make this long, and in here make this long, and this might just not work. ABCDEF becomes ABCDE, and I lose the F. Why do I lose the F? Because F goes too much to the start, and it is goddamn truncated. I lose the LSB. In this part, this till now, here, this gives me the n LSBs of x, right? Yes, this gives me the n LSB of x, and then I am left shifting them by 32 minus n times. Yes, 32 minus n times. If 32 minus n times, then those LSBs are become the MSB for that, and then I am doing its OR. Nope, I do not want to do its OR with x. No. Yep, I can do its OR with x because the other, this, the second expressions, n MSBs, like n most significant bits are 0, so I can do an OR with that. The problem is with this. How do I find out the length of x? That is the whole problem here. This would be much simpler in assembly, because in assembly I know what the heck I'm dealing with. And what is the time? 2:12. Let's see. Write a function, write rotate x in that returns the value of the integer x rotated to the right by n positions. Okay, let's do this. ChatGPT, let's ask it what the heck is wrong with this. This function is supposed to rotate x right by n bits, but it ain't working. Hmm. But there are issues with the implementation. Incorrect mask calculation. The mask calculation, a mask of n. This is supposed to be left. This is supposed to be left shift. Now does it work? Sort of, sort of, sort of, pretty much sort of. It works. It does not. It does not. You does not. You do not count that as working. But yeah, we got somewhere. Right, that's somewhere. Then left shifted my 32. Left shift that by 32 minus n times. Is that what I want? Okay, this produces a mask within zero, so I have to do a rotate right and sign in and what does it do? Shifts x right by n bits and then shifts x left by 32 minus n. Yes, I can do directly that 32 minus n. That makes much more sense than hard coding it like this. And the question is, will this work? This is, I guess, mathematically equivalent to what I was doing before. Oh, for binary, I can use b here. But then to use only. That seems correct. Yep. So that is done. And tomorrow we will start with this. Our goal for today was to complete this chapter, but we could not. We have only this remaining, this assignment operators and expressions, which is about this long. Then conditional expressions, which also has a single problem, and then precedence and order of evaluation, which is pretty simple. Then we can start with, we will start chapter number 3 tomorrow after completing all of this. That is good. That is good speed. And bye for today.